tinker today, Wiz.
Born ready. Yes.
So fine tuning in 2026. This is crazy. Do people still do this, Wiz?
Oh, they still do it.
It's still happening all the time, isn't it?
Yes.
Quietly.
I wouldn't say quietly. I would say loudly.
Yeah.
Very loudly.
Yeah.
But
you're in a specific part of the world. It seems
yes.
quiet to me. I hear about agents all the time. I don't hear many people talking about fine tuning. I don't really see it much in the newsletters. I don't see people posting about their sweet fine tuning job they just did. But when I saw Tinker a couple of months ago, actually, I was like, man, I feel like I really want to cover this. Thinking machines coming out with their lab after leaving OpenAI is very exciting. Kind of what's going on there. And then they released this API for fine tuning. And I thought, that's curious. But it wasn't surprising to you. Why not? It surprised me. I haven't seen people talking about this stuff.
Yeah, I mean, I think it's just, again, if you're in that part of the internet, right? Like if you're in the space of fine tuning, then you're going to see fine tuning. And whenever a new leap comes up that's being shared with all of the, frontier research shops, then you just kind of hear about it. It's also something that was rather quietly launched, I would say. It was in like private beta for a while, and then they just kind of like said, okay, everyone can use it. But it's not like there's been these there's been no Super Bowl ad for Tinker. Let's say that, right?
That's right. Yeah. So, I mean, we removed fine tuning from our course in 2025. And the reason was because it kind of became this table stakes thing. Like you're going to kind of need to know how to do it, but it's almost like prompt engineering or something. It doesn't deserve its own class anymore. And with the Tinker API, I mean, it's not exactly the newest idea in the world that we're doing training through an API. I mean, you can do this on OpenAI. You can do this in a ton of places. We've seen this over the years. 2024, we were covering tools like this. What strikes you as different and worth covering today in a nutshell? We'll get into it deeper as we go.
I think in a nutshell, right, this is basically, you can imagine that we use frameworks like this, like PyTorch, famously, right?
Yeah.
And when we use the PyTorch API, it's like an API in the traditional sense, but it's not, I think, an API in the sense that people think of like a web API, right? Tinker is. So the resources don't live on your computer. They don't live next to you. They're managed by Tinker in the cloud, right? And so this is, I think, I would say, like the core idea is you use it like you would one of these frameworks that's on your machine right over here. But instead, it's managed in the cloud for you.
Yeah, it struck me as it's kind of like data science for AI engineers or something.
That's right.
It's sort of this, and that's not a new idea, but perhaps the implementation and the quality of it and the people behind it and the interesting story that is potentially going to unfold here. That's the interesting thing. Okay, let's kick this thing off. You ready to rock?
So ready to rock.
Let's do it.
Let's freaking go.
Here we go. Welcome to Tinker, everybody. Welcome to another AI Makerspace Weekly Wednesday event. We're going to cover more on models this year because we want to do a little bit more of this more advanced content. Now, for those of you that are just getting started with this stuff, if you're joining us today or checking out this video, we're going to cover a lot of higher level details about fine tuning, about RL. You may need to dig deeper into our YouTube channel because we have covered the fundamentals of a lot of this elsewhere. And so this is going to be more geared towards advanced folks that are quite familiar with fine tuning and RL already. Okay, so with that, let's line ourselves to the rest of the session today. Why should we care about a fine tuning API in 2026? When should we use it? what's really new here and what's not. And then, of course, let's build, ship, and share with this. And let's wax a little bit poetic about the potential futures ahead of us at the end of this session. Thinking Machines Lab, what are they doing exactly? What do we expect from them? This is kind of an interesting, low-key company and space of the world that maybe you don't spend too much time looking at. We'll give you our 2 cents on how it's evolving at the beginning of 2026, at the end of today's session. Okay, so Tinker, what's new? What's not so new? Is this using an API really all we need to do anymore if we're not doing LLM pre-training from scratch? Let's talk about it today. Okay, Tinker is just a training API. As they say, it's for builders, it's for developers, it's for researchers. That sounds good to us. And the training API allows us to control every aspect of model training and fine-tuning. And essentially, they deal with the GPUs. They deal with the compute and the infra. They deal with all of that. And so, you can kind of start imagining a world where we can dispense with these data scientists waiting around while model trains memes. Now, importantly, when we say training and fine-tuning, or we say alignment and RL, we're kind of talking about the same thing. Again, if this is not clear to you, please check out some of our fine-tuning or alignment playlists on the YouTube channel. But there's a fundamental sameness about the techniques that we're using to do these things. And we'll see some of that today. But, the big idea of training is that it takes a lot of compute. The big idea of fine-tuning is that historically it's taken a lot of compute. And models keep getting bigger. It's getting wild, right? This is a screenshot from today on Hugging Face. We got models over 500 billion parameters. We got models that are 1 trillion parameters. And this is kind of a wild world we live in. This is from the Thinking Machines blog on why they use LoRA, low rank adaptation, with no regret. Today's leading language models contain upwards of 1 trillion parameters, pre-trained on tens of trillions of tokens. Base model performance keeps improving at scale as those trillions are necessary. Necessary trillions to get all of the richness of human data and knowledge that we've written down. Of course, this presents a few challenges. To fine-tune 1 trillion parameters means you have to fine-tune 1 trillion parameters. To store and deploy 1 trillion parameters means you have to store and deploy 1 trillion parameters. This has been the problem all along, okay? Here we are in a new year, but it's the same old low-rank adaptation that we're using to help solve this fine-tuning problem. And it also helps us solve the storing and deploying problem. Now, how Tinker works is TLDR, LoRA, but we write a simple loop. We include the data or the environment, and we include the loss function. Then Tinker figures out how to make all the training work. That sounds good. So we might imagine that this is kind of like you just give it a simple prompt input and we get this awesome fine-tuned LLM. Well, that's not the case. It's not a magic black box that makes fine-tuning super easy. It's it's an abstraction. It allows us to kind of not have to worry about the distributed training stuff, not have to worry about managing compute, waiting on GPUs to run, and it allows us to focus on the data and the algorithms. It allows us to focus on the data and specifically what exactly we're doing in our training loop, what loss functions we're using, what evaluations we're using. So the idea is that with the training data and training logic focus, kind of we can focus on the software, not so much the hardware. And all we need to do is we need to write simple Python script and set these things up forward, backward, step, what to sample, where to save. And again, we're going to kind of gloss over some of these details if you're not familiar with training and fine tuning. But this is going to make a lot more sense once you have that familiarity. Now, the features are not kind of mind-blowing here. They can do VLMs, but only image understanding, a classic. Fine-tuning, just LoRA. A cool feature here, though, is you can actually download and publish the weights. Again, Hugging Face, anybody, right? Like this isn't exactly new. But so Wiz, what I want to do is I want to kind of go back to this magic black idea. This seems to me to be the promise of this entire space, and it always has been, this sort of auto ML space. I just want to tell you what I want, and I want you to go figure out how to train it. But that's not what it is. It's just kind of, you mentioned PyTorch before. You know, there's these other tools out there like Hugging Face, you know, like Axolotl, like these open source fine tuning things. Of course, our friends at Unsloth are doing a ton of great fine tuning work. Is this really just a wrapper around PyTorch for us? Is that all it is at the end of the day?
No, I mean, I mean, definitely not is the answer, right? Okay. I think the way you could think about it, though, is that it is a wrapper around stuff like PyTorch, right? So, and specifically, it's a very abstracted wrapper. So it's not like these kind of lower level wrappers, right? So Hugging Face, all these are doing the same kinds of thing. They're giving us a new API to use the thing that's sitting next to us for the most part, right? This is it is meant to be a system you can use where, again, it's abstracting all of the infrastructure away from us, right? So we can use the same, they could make huge changes, right, to their infrastructure. And as long as there's no breaking changes for the API, we simply don't care, right? If they make huge optimizations, we just kind of, you know, you hate to say it, but we get those for free, right? And I think that's something that's very useful because, again, it's abstracting us away from the actual from the actual implementation.
And you're saying that this is not necessarily the case with some of these lower level implementations.
Yes. Yeah. Well, so
I mean, it's a race, right? Everybody's trying to get to the same place and become the best and most meta.
But because of the way they're doing it, right? It's web APIs, right? You submit jobs to their web APIs.
Yeah.
What I don't want to do is make the claim that this is something that it isn't. And what I want to do is make the claim that this is incredibly useful and powerful. But it's handling a lot of that specific hard part for us.
Okay, so like, just let's make it concrete for everybody real quick. We used to teach fine tuning a lot, and so what we did is we taught people to pull down the model from Hugging Face, to do it in a quantized way, to then set up their fine-tuning job, to write this loop, right? But then we also needed to go and allocate GPU time through Google Colab typically. If they didn't have hardware that they had locally, we had to go and make sure that we had access to the right, and people ran into a ton of issues here, right? Like, well, which size GPU do I need? And well, if you get a bigger one, it'll go faster and blah, blah, blah. And all of kind of the headache associated with that is kind of going away. So it's almost like it's optimized for by removing some of the things that we have to do. So it's not, especially for beginners, as tangible of a wow, this is so good. But we get the openness that we don't get when using OpenAI. We get the openness that we don't get when even using some of the things we covered in 2024, like gradient, for instance. It's like in some of the tools that, will offer you fine tuning through their platform, like a lot of these MLOps tools out there that we see, and these platforms that you can fine tune whatever. It's just like everybody is kind of coming at this in kind of slightly different ways, and it's a bit of a total package vibe I get from Tinker. Is that how you think about it?
That is a great way to think about it. Yes. So I think that answers the question more concretely. That is a good way to think about it.
But we're still in the notebook, right?
Yeah, 100%.
Yeah, we're still doing the training in the
our
notebook.
Workflow isn't changing, right? And the beautiful part is that our it's the same like any web API. Our flow doesn't have to change for so long as they continue to maintain their API well, right? Yeah. We can keep doing the same old stuff that we've been doing. Very, very useful in my estimation.
It strikes me as a no-brainer for data scientists to learn. Maybe that's the point I can end on here. Is just like if you're in the notebook and you're training models and you don't know anything about APIs yet, well, here's your sign.
Yes.
Okay. All right. Cool. Look, let's dig into a little teeny bit of the theory, especially if we have beginners joining us today, and then we'll kick off the demo. Okay. So what's not so new? Let's look at this again. How it works. You write a simple loop, include the data environment and the loss function. Remember, this is still true. All fine-tuning is basically done with LoRA. New year, same old LoRA. Picking up on this thread from their blog. Trillions of parameters. This is necessary for pre-training. In contrast, post-training involves smaller data sets. Generally, we're focusing on much narrower domains. This is where we get our company specificity. This is where we get our more specific user information that we want to kind of flavor and get the vibe of our LLM or our agentic system really locked in. And it seems wasteful to do this without something like LoRA. So they had a great image. It's just kind of like, cooler looking than typical LoRA images. The easy way to think about this is LoRA creates a low dimensional representation of the updates. Now, the way that this happens in brief is we're just using a matrix decomposition. Classic, if you've ever studied matrix algebra. These two together are much smaller than a big one. And this matrix decomposition is just a way to convert a difficult problem into an easier problem. And the reason that this kind of works is because within the LLMs, there's this idea of this kind of intrinsic dimensionality. So when we train these pre-trained models, and we do it on these tens of trillions of tokens, even though we needed all that to get to the weights the weights themselves now, and the ones that kind of matter the most, like most of the weights are 0. Okay. And so this specific the specific important weights can kind of be dealt with much more efficiently. And this is, again, not a new idea. LoRa takes advantage of this idea. So we essentially take the original weights and we freeze them. And then we inject new adapter matrices here that we're going to essentially be able to plug in, multiply by the whole thing, and use. And these trainable rank decomposition, just meaning we've decomposed the matrices, we have this intrinsic dimension, this intrinsic rank, we can then plug into our LLM. And we can kind of visualize that. This was great from like an Apple on-device marketing piece, these kind of adapters that you can do different things with from 2024. And these adapters for many different tasks are kind of one of the key things that we love about LoRa. We can, of course, also note that we get basically just as good results. That's the utility of having that intrinsic dimension we're working with. And, so in the end, right, this B and A matrix together have way fewer parameters than the whole LLM. And this ability to kind of use adapters, we can add a fancy word in here. This is what Thinking Machines is calling multi-tenant serving. We can think of, right, a tenant as like a group of users that shares access to like a single instance of a software application or of a cloud service. And so these adapters are kind of sharing access to the LLM. And since we train LoRa on this adapter while we keep the original weights, we can have kind of a single inference server. And at inference, we can swap the adapters, which is dope. And this is how like VLLM works and other inference servers. So essentially, we want to be able to update fewer things. And so we are parameter efficient in our fine tuning. And this is a great blog. We'll talk a little bit more about this after the demo today. But this article on LoRa Without Regret was basically them saying, hey, we did a ton of experiments with LoRa. And we were like, yo, LoRa is pretty dope. The outcome of the experiments was that even though they went way beyond what people had done in the past with LoRa, they are embracing this kind of low regret regime with their decision. And just to kind of circle back around to this, like what's actually new here, the key thing that's new here is that Thinking Machines is doing it. This is kind of foundational to the promise of this tool. And as far as I can tell, this is the new thing. Wiz, am I missing anything about what's new here?
No, I mean, the reality is
in the code. None of this is new. Like, it's like,
it's not like I don't know. I would think of it less as like new, right? The idea is that it should feel great. It should feel normal, right? And then all of the newness again is abstracted from us. That's
like when they release a research paper later and they tell us about all the micro optimizations they did, that's what's new.
Yes.
Like DeepSeek, right?
Yes.
Like DeepSeek doesn't tell you until after. Something like that, right? That's what these leading labs are doing.
Yeah, we know from their blogs kind of where they're going and what people care about, right? So we know all of those things. But you're right to say that until we get the report that says exactly what their infrastructure is and why they're doing it, and we're kind of just guessing. What is true and what needs to be true, and is what is most important to be true, is that when you use it, it works good, right? And so whatever they're doing, at least for now, it worked good. And it worked good. Many thumbs up, right? So
That's right. That's right. That's what we want with our developer tools.
Yeah.
And I guess the other
The
thing
most
is
important thing I would say, right, is that it works well.
and you can do big models with it too,
Big model.
right?
Oh yeah.
Which wasn't necessarily true with some, like I saw some 223, 235s, some MOEs. You can fine tune the MOEs.
You're gonna pay, but you can do big,
Yeah.
Oh, yeah.
You can do big easily. That feels, I don't know.
That feels good.
Maybe newish. I don't know.
Right?
Yeah. Okay.
New is such an interesting word, isn't
Yeah.
it?
Is it really news though? I don't know. In your part of the internet, no. In mine, perhaps. You decide for yourself out there. Lovely AIM community members and viewers today. Okay, I'm going to introduce this demo and then I'll hand it back over to you, Wiz. Okay, we're going into how to tinker. Now we want to focus in on a couple of different words here. We're going to do an RL thing here because it's cooler and it's newer and because everybody loves RL in 2026. Not many people loving that SFT quite as much. My opinion, not Wiz's. Okay. So we're going to set up the environment and the loss function here. Now, if you want to know more about RL with verifiable rewards, check out the event that we did on this late 2025. But in short, we want in any kind of RL thing, want the RL to kind of play this game with us. And when we're going to verify if the RL did it right, not just see if the human thought it was pretty good, we want to measure whether or not it kind of wins the game. In fact, we want to verify whether or not it wins the game. And if it wins, we give it a reward. Now, whether we're doing RL VR or we're doing RL HF, also which we've covered on this channel in great depth, it's important to note that when we do provide a reward, what happens next is we are updating the weights. This is where LoRA comes in. This is where these things connect. And this is where I want you guys that are, a little bit new to this to kind of think about where the fine tuning does come in. So whether we're doing alignment, whether we're doing SFT, whether we're doing kind of anything that is going to do a weight update and modify future behavior, LoRA is going to come into play here. So we're going to play a game. It's called Guess the Number. So let's get tinkering with the Tinker API. Wiz, it's time for you to put on a show.
Yes. Okay, so you might think, why guess the number? Isn't that silly? It is. Okay, you got me. But we need to do something a little bit. We need the complexity of the tutorial to be about what Tinker is, not what the training is. The idea is you can train whatever you want. That's the beauties of Tinker, right? So let's look at what we have now. You're going to notice that we have a .env file because there is a Tinker API key. But other than that, that's all we need, right? And we don't need to be using a GPU. We certainly don't need to care about what the GPU is. We care about none of that, right? We need an API key, and then everything else we need is like entirely separate to an API key. So what I'm going to do is walk through the first part of the notebook, right? This is a beautifully drawn diagram by my good friend Claude, because I'm bad at drawing diagrams. But the idea is that we have our machine, which is doing stuff, right, on the CPU, and then passing off to all them GPUs. So it's not like we're submitting the full job and then waiting for the full job to be done, right? We have control of the training loop on our machine, and we submit parts of it to be done. Now, there's a lot that can happen here. Okay, so I'm talking about it like it's very simple, but it's an excellent feat by the the Tinker team. So Thinking Machines is doing it right. Well, there you go. We have some preamble about what RLVR is. We have our Tinker API key, and then we're going to import some stuff. We're going to import hyperparameters, and we're going to use, by the way, Qwen3 for Instruct, because that's a small model they have on their platform. Now, something interesting here is that, you see, we set all these hyperparameters just like we would if we were training a model using our local machine, but we're not. There you go. Isn't that interesting? We're then going to go through some preamble about LoRA. Please read it if you aren't sure what LoRA is. We have some understanding on what the actual training client is doing. And Thinking Machines is very much, LoRA pilled, right? They care a lot about LoRA. You can read some really excellent blogs that they've written on LoRA if you want to learn more. But the idea of what we're going to do is we're going to go ahead and we're going to you should be seeing the notebook on the screen. If you can't see the notebook on the screen, I'm uncertain why. I think that it's on the screen, and maybe behind the scenes legend Jacobs can figure out what's going on there. But yeah, so you should be seeing my notebook on the screen here. The idea is that we have like normal RLVR, which is single turn RLVR. Saying normal is a bit silly, but no notebook on the screen is an interesting one. Let's very quickly. It's true. The notebook does not appear on the stream. So let me remove it and re-add it and see if that takes care of the problem. Let's see. Indeed it did. We have a notebook now. Okay, perfect. So the idea is that we have this idea of a single turn RLVR, which is like one back and forth, right? So I say thing, model gives you response, I score response, boom, boom, boom. Okay. Then we have multi-turn RLVR, which is what we're talking about here. Multi-turn's a little bit different. We move through a series of actions, and then we reward the whole sequence, right? So instead of just giving a reward for one correct answer or zero correct answers, we're actually going to look at the whole trace and then reward it. So all of them are going to get reward. And this is all something we can track through this idea of a game state. Now, the game that we're using is this guess the number game. The reason we're using guess the number, though that might seem silly, is because it makes sense that the model might not know the optimal strategy for it, right? You can always win guess the number optimally by using assuming that you're playing against a perfectly logical opponent. You can always win by cutting the remaining number of options in half, right? So you should always choose a number which splits all the other numbers in half. Obviously, there is caveats to this, and you can watch mathematicians wax poetic about what the actual optimal strategy is, given that humans aren't perfectly logical creatures. But assuming that we're playing robots, which in this case we are, we should always use what's called binary search, right? But the model is not very good at that out of the box, and so we can see that, right? We're going to create our client for our actual model that we're going to use. You can see that we're creating a LoRA training client. We're going to pass in the base model and its rank. We're going to initialize our training client to get a sampling client. Now, the sampling client is like the thing we can do inference on. So what we're going to do now is we're going to play the game, right? And we play the game by passing in our sampling client. We provide a secret to initialize our game state. And then we keep playing the game. We're going to keep playing until the model gets it right. And if it fails to get it right, then hey, you lose. So in this case, before training, we get that the thing won on 3 turns. Good job. So now we're going to evaluate. And over the course of 20 games, we win 2 out of 20 of the games, right? So the model's clearly not like nailing this task. It's still good, right? It could definitely get the dub, right? But it's mostly getting the dub by randomly guessing numbers, right? Which is like cringe. So here we do our RLVR training loop. All kinds of stuff in this diagram, but the big thing is that we're going to use this as our training loop with our forward-backward pass, right? Which we can see when we get to our training loop. We can also see that we can set our Atom optimizer with the hyperparameters we want, our sampling parameters with the sampling parameters that we want. Maybe we're using a model that demands a high temperature. We can change this here, etc. And then finally, we have our game trajectory. This is going to actually build a trajectory for the whole game that we can then score. Easy peasy, lemon squeezy. Yes. Okay. Then finally, we have the actual training. The actual training is very straightforwardly the training code. This is just like any other training code, right? You can see we have our TQDM, just like we would if we were doing this for realsies. We can grab our rewards. We have our training datums. We're doing everything like looking at the log probs. This is what we normally do, right? This is all stuff we normally do, right? We have our forward, backward, we have our optimize, we have our results, and then we log them out, and then we run the training, and you can see that we train for 5 batches. After we do the training, we find that we win 3 out of 20 games with 5 batches. Obviously, we would want to continue training on and on. There you go. Okay. Yes. Then we play the same game we did originally, and we nail it. Boom. There you go. We get a small bump, right, for training our model with Tinker API. The big thing here, though, is this is only 5 batches, right? So in reality, we want to run it for even longer and longer. The big thing, though, is like this is all totally handled for us in terms of infrastructure. But in terms of the training loop, like if we scroll back up, excuse the scrolling, we're building all of this, right? We build every line of the actual training logic, right? We only move to the infrastructure when we need to, right? Including things like the loss function, which we have a control over, the data, which we have a control over, how we're using our optimizer, which we have control over, right? All of these things are up to us, and so we can build whatever training system we wish. This is the idea, right? This is the main idea. Yeah, Tinker. This is what it does. There you go. With that, I'll pass you back to Dr. Greg. And if you want to see more videos like this, we're going to be live every Wednesday at this time for the rest of the year. So please subscribe, ring the bell notification. There you go. Back to Dr. Greg. That's Tinker API. We control all of the training code, and we have to worry about none of the GPUs.
That's Tinker. So, I mean, you just did a kind of a stupid example there. Okay. So like, but people, when they're going and they're going to maybe use this in their job, they're not going to be doing that exactly. Guess the number. How can the typical AI engineer here start to think about when they're going to pick up Tinker, what kind of applications and use cases they're going to use this for, where it fits into their tool stack exactly?
If you're training a model, which you may well be, and the model that you want is on the list of models on Tinker, just use Tinker. period.
If you need to train model, that means fine-tune model, that means RL. Typically, if you're an AI engineer, most people aren't training from scratch.
Yep, that's true.
So if you decide I need to do fine-tuning,
yep,
I'm going to Tinker.
100%.
What about our boys at Unsloth? When should we go pick up their stuff?
Yeah, this is something that I really want to make sure we're clear about, right? Because it seems to be getting a little bit confused. I mean, Unsloth is good if you're training small models on. You want to train models on unique hardware, let's say, really quickly, right? In a very experimental fashion, right? But like Unsloth isn't something that I'm going to point to for huge training jobs with many, many layers of experimentation where stability is of the utmost importance, right? Unsloth basically works by monkey patching exclusively, right? Which makes it amazing for what it's good at, and then less amazing for everything else, right? It's like saying, well, when should I just make an application versus using an application? I mean, of course you can answer the question, but like I think it's losing you're losing the plot a little bit, let's say.
Yeah. Okay. So,
and just to be clear about all of that, let's call it, maybe it was like I don't know, 10 to 15 runs.
Yeah.
That I did to find a use case where there showed improvement, but was easy to understand, right? So
yeah,
started with like addition. Models are so good at that. Moved to multiplication, too good at that. Moved to getting some square roots, too good at that, right?
Yeah.
Finally, guess the number game. Models haven't distilled into their reasoning that you should always cut the options in half yet, right? So, and all of that cost me a grand total of 5 cents.
Oh, okay. All right.
It's not a lot. It's not a large volume of training, but like it is something that you can do quickly and relatively inexpensively based on the model you've chosen.
That's right. Okay. And so then, like, this question from Charles here, what's the best parameter to use to limit spend? Like, when we talk about parameters here, I think this is the point, right? Like, this is where the tinkering comes in.
Yeah.
I mean, it's like, well, what are the best things to use? It's like, well, that's the right question. So this particular one, though, what do we think? What is the best parameter to use to limit spend?
Yes. I don't think that there's a perfect answer for this. Choose small models and be well aware of what the cost is.
Yeah. Don't choose the biggest, baddest model.
Like the cost is laid out very effectively on in their docs. You can build scripts to help you understand what the cost is going to be, right? So be aware of it. Don't just YOLO into the void.
Okay. All right. I want to do something a little bit special and different today, Wiz. So I guess just hang out up here, and what we're gonna do is we're gonna look at what Thinking Machines is saying. Okay. And we're going to consider what we think about it. And part of the reason for this is over the past few years, we've noticed that companies are changing what they say about themselves all the time. So we're going to look at this Thinking Machines Lab page together. All right. And then we're going to think, okay, what are they doing here? And we're going to get all the words down for posterity so people can come back to this video and to this thing when all the words change on their main website, thinkingmachines.ai. We accessed this on January 14th, 2026. Okay, so it's an AI research and product company. Okay, what a classic. What a classic. Key gaps are remaining today in AI. And despite their potential, the systems typically are still difficult to customize. Maybe not for folks like you, Wiz, but for the most people out there, most companies out there, still very, very difficult. So Thinking Machines, and then they're gonna pepper us with some additional bullet points here. Science is better when it's shared. Agreed. So they got this open source vibe. And love that. Love that. Mission driven. AI that works for everyone. Emphasis on human AI collab. All right. Not embodied yet, but they're going multimodal. More flexible, adaptable, and personalized AI systems. Also dope, I guess. Okay, solid foundations matter. Model intelligence as the cornerstone. Infra quality as top priority. Okay, that kind of aligns with our demo today. They're taking care of it for us. And then multimodal is the future. Okay. Finally, learning by doing. Oh, love this. What a classic. Did AI write this? I don't know. Research and product co-design. Empirical and iterative approach to AI safety, measuring what truly matters. So they was 2 billion, I think, in like 6 months. And I want to come back to this idea. We said that's not what Tinker is. But like, could it be? You know, like, is this, you know, the true auto ML is, hey, I want this model to do this. And then the chat comes back and it's like, okay, well, do you have data? It's like, no, I don't have data. And it's like, okay, I'll get some here. You like this? And it's almost like the next level of prompting is fine tuning or something. Is Magic Black Box on the horizon here in your opinion,
Yeah,
Tinker?
I think so.
Yeah.
That doesn't mean that it's true.
Again, for posterity, right? Okay.
But like, yes.
Okay.
I mean, if you look at the history of different big companies and you look at what thinking machines kind of stated missions are, I think I'm biased because I think this, right? But I do think that there is a considerable chance that this is what they're trying to do, right? Which is input prompt, get back model. You know what I mean?
I mean, like, I don't know. What do you guys watching out there think? Would you use it? I mean, it sounds pretty cool. I'm not even sure. It's kind of too meta to think about exactly what I would use it for. Although it's kind of like, yeah, the next level of prompting. It kind of just becomes, it's meta prompt. Yeah,
that's right. Meta prompting.
It's just more meta, dude. We just keep entering the meta zone here. Like tinkering becomes like everything converges on natural language in the end.
That's right. And it kind of makes sense that they want to do this. I you know, again, I'm not gonna.
You don't have any insider info here.
Yeah, but I do want to say that I believe this is true.
Yeah.
Now, you know what I mean? And
yeah, we said it now,
and we've said it, and so now if we're right, that's dope.
Yeah,
you know.
Well, I mean, I think about what Cursor did, and Cursor's like, we're going to build this thing, and we want people to use it for this, and then we're going to use the way that the people are using it for this to make us better at providing them the thing. And you know, it's like, okay, well, Tinker, it's like we want people to use it for training. We're going to work with those people, collect their information about how they did training, and then we're going to make the thing better at training over and over. And if we think about the iteration cycles on Cursor that happened over the last year or so, you know, it's like it got a lot better. A lot of other coding tools did too. Maybe this is a new paradigm we're seeing here that people will, kind of this positive feedback loop of using users to train their meta model. I don't know.
Yeah.
Getting out on the edge here.
And again, like they could just do this stuff behind the scenes and we would never know. Right. And at some point we could be using it and there could be a clean transition. All of this to say, I'm excited for the future of this product and what they're going to do, how they're enabled.
Okay. All right. One more thing that I want to move into to discuss, because now that, if is this team really, really capable? Well, I mean, they seem to be going deep here, like if we go a little bit deeper into what they've done here, LoRA without regret. Okay. Blah, blah, blah. We know it's, they're going to use LoRA. Well, here's what they actually did. And we can kind of walk through this again together here. They kind of said, well, we did a few things differently from previous experiments. And I'm not reading anything on the slide right now, but they said we investigated the general relationship between set size and number of LoRA parameters rather than focusing on specific data and tasks. And then they measured with SFT log loss rather than employing sampling-based evals with the goal of generality in mind. Okay, so that's the sort of preamble here. Now, what did they find? They found that for supervised learning on small to medium-sized instruction tuning and reasoning data sets, LoRA performs the same. Surprising or not surprising?
Not surprising. This is kind of relatively... This was slightly intuition based and also based on some work that Sebastian had done, kind of not like known to be permanently true, but it was a very much an expected
Rashka.
Yeah, that's right.
Yeah, okay. And this, by the way, this blog was written by John Schulman, who I believe was one of the original. I don't remember his exact title at OpenAI, but he was OG.
Legend. Yeah.
Absolute legend. Okay. Next, for data sets that exceed LoRA capacity, well, I mean, by definition, right? LoRA underperforms full fine tuning. So we have this interesting idea of there's a capacity to LoRA.
Yes.
And it's related to the data set, interestingly. Not necessarily.
Yeah, I mean there is. I mean, LoRA has tuning knobs, right? So it I think for this specific blog, I believe this is talking about rank 1 LoRA, if I'm not mistaken, right? And so there's a big difference between like rank 1 LoRA and rank N LoRA, because rank N LoRA is full fine tuning, right? Where N is the size of the previous matrix. So there's this idea that like there is an amount of information that will saturate your rank 1 LoRA, and using data sets that exceed that, you find that there's not benefit to using LoRA, right? But it kind of makes sense. It's like if you fill up a bucket and then you add more water, there doesn't get to be more water in the bucket.
Still full.
It's still full.
Yeah.
Yeah.
Well, and there's another, we've gone into depth on the transformer before, right? And like you can actually put an adapter in a lot of different places within a transformer model, right? 100%. Like you can put lots of different adapters if you want into different layers.
Yes.
And so like the idea that there's one way to put a LoRa adapter in is, well, that's just not true, and
100% true.
So there's nuance here that I think it's worth highlighting as people start thinking about, fine tuning in the age of, agents in 2026 and beyond. Okay. Let's see what we got next here. Okay. Let's pick another color. In some scenarios, LoRa is less tolerant of batch sizes than full fine tuning. Also intuitive.
Yep.
Okay. I'm not sure there's a ton to say about that.
Nope.
Even in small data settings, LoRA performs better when applied to all weight matrices.
Yes.
Well, that's kind of what we were just saying, right? Like, put adapters on all the layers. Is that what this says?
Yeah, basically,
especially the multi-layer perceptron and mixture of experts layers. Maybe all of them.
This is like, so this is kind of what we saw with things like QLoRa, right? So OG LoRa was like, oh, we're going to be very targeted, QKV or whatever. I don't know if you remember the early days of LoRaing, but that was, but I think since QLoRa, this is again something that has been like largely believed to be true. And there's been a lot of like intuition building and papers that have kind of, as like a side effect, put this into the results. But it's just nice to have consistent confirmation that like the things that are intuitively true are true.
And finally, and perhaps most interestingly for 2026, I don't believe most people associate LoRa and fine-tuning with RL, although RL is a type of fine-tuning, but it performs equivalently to full fine-tuning for RL. This is maybe the most interesting thing for training our agentic systems. And like we're talking with Lucas a few weeks or maybe a month back about kind of how this idea of like we want to kind of optimize and align maybe the whole system. It's got tools, it can go do this stuff, it's got an environment, it's got this place it operates in. Want to optimize that whole thing. And maybe part of that is kind of this fine tuning of the system, maybe.
Yeah. So yeah, I mean, it's
when are we going to be fine tuning agents, Wiz?
We should be fine tuning agents all the time. Customization is the future. That's what I believe. Is it true? That's a great question.
Yeah.
But is it what I believe? Yes.
If you're not fine tuning agents yet, you're behind. You heard it here first, everybody. God, yeah. It just keeps mixing together, Wiz. It just keeps mixing together.
It do be mixing together. The big thing is like this makes intuitive sense, right? Like or at least I believe that it should make intuitive sense, right?
Why is that?
Because
an RL environment is more constrained fundamentally.
Well, but I mean the broader point you're making, that we're fine tuning everything, that we're customizing everything,
okay?
Right? Because the models are not trained for what you're doing. You know what I mean? It's like almost definitely true that the model is not trained for what you're doing, right? It's probably true that the model is trained on like similar things to what you're doing or very close to the same, but it's definitely not trained on what you are doing and what your users are doing, right? And so customization has to be the end game for any of these systems, because customization is it's like everything else that we have, right? Like your car, like your house, like your toothbrush, like your toothpaste, right? It's like these are things that you pick the one that's best for you over time, and they keep producing newer and more specialized ones for you. We went from scrubbing our teeth with plants to Sensodyne if you have sensitive teeth, right? It's like this is the thing. We're able to do it so much faster. In terms of the intuition behind the LoRa thing, we kind of knew that was going to be the case, because we knew that the whole point of RL is that it's not very information dense, right? This is like something that again was intuited, but I mean, making it so is different than just being like, that's the vibe, right? So
yeah, it's something like the space of everything associated with a model is something like the space of everything associated with the data it was trained
that's
on,
right.
where the space associated with an RL environment is the RL environment. And so
That's right.
it's fundamentally of lower rank, we might say, of
We
less
might say.
intrinsic dimension, right?
I
Okay.
bet we might say.
Yeah, look at that. Okay. Thank you, Wiz, for your insights. As always, it's time to wrap this thing up and conclude. See you next week, my man.
Let's go.
Tinker, the API for training. It just works pretty good, guys. It works for SFT. It works for RL. If you're a data scientist or an AI engineer, you should probably pick it up and start tinkering, at least know about it if you are ready to do some fine tuning or RL. And it's something like the completeness of the product offering that sets this thing apart. Thinking machines, we'll see what they end up doing in the future. Maybe they are building the super meta fine tuning tool. We just ask it and it figures it out for us. LoRA is not new, but they did some kind of cool studies on it. And this customization is, of course, the future as we continue to move ahead into it. Didn't see any questions in the chat. So we're going to go ahead and wrap today. Thank you for joining another weekly Wednesday YouTube live session from AI Makerspace. We are on a mission at AI Makerspace to create the world's leading community for people like you who want to build, ship, and share production, LLM, and AI applications. We got folks around the world joining us live on YouTube today and that have joined us in every single one of our cohorts. We just kicked off cohort 9 of the AI Engineering Bootcamp last night. Shout out to anybody joining us live on YouTube from cohort 9. Pratam saw you in there. And if you're interested in joining what we're going to call the 1.0, the AIE Bootcamp in April, throw in your application now. But if you're not so interested, definitely hop in our Discord community. It's the next place to find cool, competent, awesome builders, shippers, and sharers every day of the week. We got over 3,100 folks there ready to engage and that are trying to get on the path just like you. So look forward to seeing you in there. And that's all we got for you today. Next week, we are going to do RLMs, guys. Okay, it's coming. Recursive language models. We're going to keep going deeper into models this year. We're excited for it. So join us back next Wednesday to cover RLMs together and see what that's all about. Until then, and until next time, keep building, shipping, and sharing. We'll do the same. Have a good week, everybody.